Hello. So today we'll do question number 4 of this paper 1, and so let's begin. So question 4 here says relative to origin O, the position vectors of points A and B are given by OA to OB, and now we have to find the cosine angle of AOB. For this equation, the formula um, for the angle between two vectors is given by, if you have a vectors A and you have vector B, the formula for the angle, well, it's OA and OB, then the formula for the angle between those two vectors from point O. So if you have point O, A, and B, then the angle theta between them. Sorry for the mess here. So yeah, O, A, B, vectors B to A. So the formula would be vector OA, the magnitude times magnitude of OB times cosine theta is equal to a dot product of OA and dot product to OB. So the magnitude of OA here is given by 3 squared plus 0 squared plus negative 4 squared, and that's just a square root of that. So 9, 0 plus 0, 0 plus 16, 25, square root of 25 is 5. The same thing with OB here, square root of 6 squared plus negative 3 squared plus 2 squared, 36 plus 9, 45, 45 plus 4, 49, square root of 49 is 7. And the dot product of OA to dot B is given by 304 dot product with 6 minus 3 and 2. And that's 18 plus 0 minus 8, that's 10. So now plugging in these numbers into the equation, so 5 times 7 times cosine theta is equal to 10, and cosine theta is equal to 10 over 35, and now theta is just the inverse of this, and you can plug this into your calculator and to get the angle between them. So I thought you might want to know the origin of the formula. Let's say if you have a vector A and you have a vector B. The so what a dot product is, for example, if you have a unit vector I, so I is that means it's just a vector with a magnitude of 1. So if you have a vector A dot product with vector with this unit vector, that just gives, so let's say vector A and you have a magnitude vector I, and let's say this is a coordinate axis, yeah, so y-x. So the dot product of vector A to I here will give you the component of vector A on this axis, on this vector. So that means that the length here, if you have a magnitude of A here, this length from here to here, it's simply A cos theta. If it's theta, then the dot product of A to I will give a projection of this vector A onto this unit vector I, and that projection, it has a length of A cosine theta. So is this length, this is actually A cosine theta. And if you apply that principle to the previous problem, vector A and B, then I would rename OA to A and OB to E, because that just makes things simpler for me. So if for B to be a unit vector, B hat, that is b divided by the unit vector. Oh, we are not solving any problem here. I'm just trying to give you an insight of how this formula came about. So b hat a unit vector b is b vector b divided by magnitude of b. So if you have a vector a and you have a unit vector b hat here, that this, and you multiply the dot product, that will give, if you multiply a by b hat, that gives the length of a in the direction of b hat. So that's magnitude of a times cosine theta, and we know that b hat is equal to b divided by b, and that's equal to that. And rearranging the formula, you get vector a, vector b, a, b cosine theta, and that's the formula that we used originally. So now let's move on to part II of the question. Given that AB and OC has the same length, find the possible values of K. So they say the information here is given that AB and OC has the same length, that's the same magnitude. So let's first of all find the vector AB first. So if you have a vector, a point A, point O, point A, and point B, you have vector OA, which goes from O to A, and vector OB from O to B. Now you want from A to B. So that means you start from point A, you go back, that's minus OA, and plus OB to get AB. So that's minus OA plus OB. That means that AB is just OB minus OA. And applying this formula here, 6 minus 3, 2 minus 3, 0, and minus 4, and that gives an AB of 3 minus 3 and is it, yeah, in 6. Okay, so, and now we have to find the magnitude of this. That's 3 squared minus plus minus 3 squared plus 6 squared, and we were given the information that AB and OC has the same length. So we find the length of vector OC, that's k squared plus minus 2k squared minus 2k and all that squared plus 2k minus 3 all squared. Squaring both sides to remove the square roots and doing the mathematical operations, that's 9 plus 9 plus 16. So 9 plus 9 is 18. 18 plus, there's 16, that's, I mean 36. 6 squared is 36. So 9 plus 9, 18. 18 plus 36, that gives 54. Yeah, that should be right, isn't it? Well, we'll check it out later. If it's wrong, then it's wrong. So k squared plus 4k squared plus 4k squared minus, is it minus 12k plus 9? Yeah, it should be minus 6k minus 6k minus 12k and plus 9. Rearranging this to equal 0, 9k squared minus k minus 12 minus 12k plus 9 minus 54, and that gives minus 45. Should be right. And dividing both sides by 3k squared minus 4k minus 15. Let's go to next page. So that was 0 minus 0, 3k minus 4k minus 15, and oh, 3k squared. And solving using quadratic equation, that k is equal to that's minus b, that's 4 plus or minus square root of minus b all squared, sorry, it's b squared, not minus b. So okay, and I think you might see an add here. So yeah, minus 4 times a 3 minus times c, that's minus 15, and all over 2a. Let's just let's wait for the add to pass, and we'll just move on. Should be around now. Well, it's not coming. I don't know what that was, but okay. Yeah, so now it's k 4 plus or minus 16 minus, is it actually plus because you have two minus signs multiply with each other. So plus 2, now it's 12 times 15. What's 12 times 15? That's 30, 15, and that's 180. So that's just 180. 180. Oh, very convenient. And divided by 6. So now k is equal to 4 plus or minus square root of 196 plus 6. K is equal to plus or minus square root of 196 14 and 6. So you either have k to be 4 plus 14, 18 over 6, 18 over 6, that's equal to 3, or 4 minus 14, that's minus 10 divided by 6, and that's, so you have two possible values of k to give you the same magnitude. And that's the answer for question part II. So let's just check on your marking scheme to make sure that it's right. And question number 4, we had, what did we have before? We had cosine of, inverse cosine of 10 over 35, that's right. And now we have my k is equal to 3, which we have, and the other is minus 5 over 3, and that's this is the same, minus 5 over 3. Okay, so that's all there is to this question. Thank you for watching, and I'll see you next time for question number 5.